So let's take a look at friction now. So the first type of friction we're going to look at is static friction. Okay, and again, so static means not moving. So if we have our force of static friction, we say that that's always going to be less than or equal to the coefficient of static friction times the normal force, or at least in the magnitude of this. Okay? So the question is, why less than or equal to? So the best way to see that is to look at an example. Okay? So let's say we have a system. So we're going to have a block, and the block is just going to be sitting on the ground initially. Okay? We'll say the mass of the block is 10 kilograms. I know a lot of you are already shocked now because I'm actually using numbers for this problem. The coefficient of static friction is 0.5. And we'll say that the coefficient of dynamic friction is going to be 0.3. Okay? So let's look at all the forces that are on this object. So we have a gravitational force equal to mg pushing down on it, and we have a normal force pushing back up from the ground, right? So initially we're saying the block is at rest. So at rest, so the gravitational force, we're going to use for all the problems in this unit, really, even when you're doing them on exams, you can use that g is going to be 10 meters per second squared. So we're just rounding 9.8 up, and because 10 is a nice round number, and it's going to be easier for you to do calculations on the exam that way. So anytime you're working a problem, you can always use g is equal to 10 meters per second squared if you need a numerical answer. Otherwise, you can just keep it as a g. So in this case, mg is just going to be 10 meters per second squared times 10 kilograms, which is going to be 100 newtons, right? And I'm not going to go through the whole detail of summing forces because we've done that in statics already. We know that there's only two forces up and down. So we also know that the normal force, the magnitude of it is 100 newtons. Okay? And so that means, so if we look at the force of static friction, well, we said it's less than or equal to mu times the normal force. So, so we'll just look at so we'll write down, that we know that mu Fn is going to be 100 times 0.5, which is going to be 50 newtons. Okay? But in this case, we're not moving the block, so there is no force of static friction, so it's 0, right? Well, 0 is less than or equal to 50 newtons. So that holds true in the formula, and that holds true with what we would expect, right? We can't have friction if we're not actually sliding it. There's no force from friction. Okay? But now, let's say we start to push the block. Okay? So now we're going to apply a force of 10 newtons to the block. Okay? We still have gravity, and it's still the same. Like, gravity doesn't change. The normal force also doesn't change. Okay? But now what about the force of static friction? Well, a lot of people, when they encounter this situation, when they're first starting out with physics, would say, okay, well, now we're moving. So the force of static friction must be mu times the normal force, which is 50 newtons. And of course, static friction would be working against where we're being pushed. But notice this doesn't make sense, right? Because 50 newtons is bigger than 10 newtons. So if we said that we're applying 50 newtons here, then we would have a net force to the left of 40 newtons, which means we're pushing it to the right, but the object would start moving to the left. Okay? And that doesn't make sense. So we know that this can't be 50 newtons. So we know that the static friction isn't equal to mu Fn. In fact, all it means is the force of static friction is also of magnitude 10 newtons. because it means that we're applying this force, we're pushing with 10 newtons, but there's enough friction that we're not moving. So the friction just balances out the force that we're pushing with. Okay? Now let's say we push a little bit harder. So now we apply a force of 50 newtons. Okay? So in this case, once again, we look at our force of static friction, and we see that in this case, to balance out the force that's being applied, we can use the full 50 newtons. We can use the mu times the normal force. So now we're completely and totally balancing out the force that's being applied, but we're not any bigger than that, right? We can't get any bigger than that. So now, if I start to push just a little bit harder, so now I'm applying a force of 60 newtons. You know, once again, the normal force hasn't changed, the gravitational force hasn't changed. We have now a static frictional force. I'm sorry, it's not going to be a static frictional force. And the reason it's not static is because our maximum static frictional force is 50 newtons, right? That's what we're pushing back with here. But now we can only push with 50 newtons maximum back. Well, we've exceeded that by pushing with 60 newtons. So what that means is now, in this case, we go to the force of kinetic friction. And the force of kinetic friction, again, is mu kinetic times times the normal force. Well, so notice that we have a smaller kinetic friction term, right? So now instead of pushing with 50 newtons, we only have 30 newtons that the kinetic friction can act on. So we only have 30 newtons pushing back. Okay? So now, if we look at our net force, we see that if we look at the normal force, we have 100 newtons in the plus y direction. If we look at gravity, we have minus 100 newtons. We have our applied force of 60 newtons. And we have our frictional force of minus 30 newtons. So in total, this gives us a net of 30 newtons in the x direction. But remember, this is equal to mass times acceleration. So the acceleration is equal to 1 over the mass, 30 newtons in the x direction, and the mass is 10 kilograms. So this gives us an acceleration of 3 meters per second squared in the x direction and 0 in the y direction. And so this is how we deal with friction. So, you know, again, the key concepts to remember, one is obviously the formula. The force of static friction is less than or equal to the coefficient of friction times the normal force. And it's important to remember the less than or equal to. We can never have a frictional force greater than the force being applied. And you know, and again, I keep stressing this because this is the most common mistake that I see freshman students making with friction problems. Okay, we can only balance out the force that's being applied with friction. Friction can never be bigger than what we're applying, because if you did, then that would imply that you could push something and have it move back towards you. Okay, and then again, you know, static friction works up to the point where these two are equal, but once one of them has exceeded the other, then we have to use kinetic friction, which is always going to be less than or equal to the static friction. And then from there we just sum the forces just like we did in statics, but the only difference is now we say that we're going to have an acceleration that's not equal to 0, and so then we can solve for that acceleration.